Greetings everyone, I'm Christian Kinsay and I'm going to give two examples of functions, limits, the derivative, the slope, and the rate of change. First example is about function. Here's the example. If f of x equals x cubed plus 4x squared plus 3x plus 2, find f of 2, f of 4, and f of 6. Then second, to find the function f of 2, you need to substitute the value of 2 into the equation. So f of 2 equals 2 cubed plus 4 times 2 squared plus 3 times 2 plus 2. Then solve. 2 times 2 cubed is equal to 8 plus 2 squared is equal to 4 plus 4 times 4, 16. 8 plus 16 is equal to 24. Then 3 times 2 is 6. 24 plus 6 is equal to 30. Then plus 2, 32. So we will get the function f of 2 equals 32. It is also the same in regards to find the f of 4 and f of 6. First, we write the equation, then substitute, then solve, and the answer would be f sub 4 equals 142. As well as if f of x is equal to f of 6, wherein 6, the equation would be f of 6 equals 6 cubed plus 4 times 6 squared plus 3 times 6 plus 2. And the answer would be f of 6 equals 380. Next, here is the second example. If f of x equals x cubed minus 3x plus 2, find if f of 0, f sub 1, and f of negative 3. Then to find f of 0, substitute its value. So f of 0 is equal to 0 cubed minus 3 times 0 plus 2. So we will get the answer, or we solve this into f of 0 is equal to 2. Then for solving f of 1, substitute. F of 1 equals 1 cubed minus 3 times 1 plus 2. Then solving all of this, we will find, or we will get the answer f of 1 is equal to 0. Then lastly, to find the function of f of negative 3, substitute the value of negative 3 to the equation, wherein x equals would be equal to negative 3. So f of negative 3 is equal to negative 3 cubed minus 3 times negative 3 plus 2. So the answer would be f of negative 3 is equal to negative 16. Next is limit. Limit of 5x cubed minus x squared as x approaches to 7. Then to find this equation, we need to rewrite it. So for substitute the 7 to that function, where 5 times 7 cubed minus 7 squared is equal to 5 times 7 cubed is equal to 1715, and 7 squared is equal to negative 49. So we will get 1666 as an answer. For the value of the limit 5x cubed minus x squared as x approaches to 7. Here is the next example. If limit square root of 3x minus 10 all over 2x is x approaches to 3, then to solve, substitute the value as what we did in the example 1, wherein square root of the value of x is equal to 3. So square root of 3 times 3 minus 10 over 2 times 3. So 3 times 3 is equal to 9, then square root of 9 would be 3. So 3 minus 10 over 6, as 2 times 3 is equal to 6. Then solve, we will get the function of the value of the function negative 7 over 6. Next is finding the derivative. Then here are the examples. Find the derivative of the function f of x is equal to 5x raised to 4 minus 3x squared minus 10. To find its derivative, I use the power rule, wherein to find the derivative of a function, the derivative of a function would be equal to nx raised to n minus 1. So n would here is 4, 2. So we follow the procedure, it would be 4 times 5x raised to 4 minus 1, then negative minus the exponent, or the value of n, 2 times 3x raised to 2 minus 1 minus 0. So the answer would be 4 times 5 would be 20, and 4 minus 1 would be 3. So 20x raised to 3, then minus 6x. Then the next problem, find the second derivative of the function f of x equals 7x squared minus 3x minus 10. So we will just do as what we have done earlier, wherein the derivative of x would be equal to n x raised to n minus 1. So n would be is equal to 2 in our case, or in our examples. Then 2 times 7x raised to 2 minus 1. Then 3x is has an exponent of 1, so 3x raised to 1 minus 1, then minus 0. Then find the first derivative. The first derivative is equal to 14x minus 6. Then, in finding the second derivative, we need to find the derivative of the first derivative that we have solved earlier, which is 14x minus 6. Its derivative would be 14, since 14x raised to 1 minus 1 would be equals to 14. Then negative 6 would be equal to 0. So the second derivative would be equal to 14. Next is finding the slope using the derivatives. Example, find the slope of the function where y equals x raised to 4 in a point 3, 1. First, we need to find the derivative of the function of y equals x raised to 4, wherein its derivative would be 4x cubed using the power rule. Then, in theory, the slope is equal to a derivative. Thus, the slope is equal to y derivative. Since we already got our derivative, thus the equation would be slope is equal to y derivative, then slope is equal to 4x cubed, wherein our x would be 3. Since the x in a point 3, 1 would be 3. So we will substitute it, then the slope is equal to 4 times 3 cube, wherein 3 cube would be 27, then 4 times 27 would be 108. So our slope would be 108. In the second example, find the slope of the function y equals 1 over 2x plus 1 in a point 2, 1. To find the slope, we also need to find the derivative of the function y equals 1 over 2x plus 1. To find its derivative, we need to change the function 1 over 2x plus 1 into 2x plus 1 all raised to negative 1. Then use the power rule, wherein n would be negative 1. So negative 1 times 2x plus 1 all raised to negative 1 minus 1. So the answer would be the derivative of negative 2x minus 1 raised to negative 2. Then change it to the fraction form, where then the answer would be, or the derivative would be 1 over negative 2x minus 1 all raised to 2. In theory, a slope is equal to a derivative, thus m is equal to y derivative. Here would be the equation. M equals to y derivative. Y derivative is equal to 1 over negative 2x minus 1 all raised to 2, wherein x is equal to 2. So the slope is equal to 1 over negative 2 times 2 minus 1 all raised to 2. Solving all, the slope would be 1 over negative 4 minus 1 raised to 2. Then the slope would be equal to 1 over negative 5 squared. Thus, the slope would be 1 over 25. And lastly, the example of the rate of change. First example is, if f of 5 is equal to 4 and the f derivative of 5 is equal to 6, estimate f of 5.5. In finding the rate of change, the formula is f of a plus h is equivalent to f of a plus f derivative of a times h. To find h, we need to solve 5 or subtract 5.5 minus 5. Thus, h would be equal to 0.5. Then find the rate of change of f of 5.5. Then use the formula f of a plus h is equal to f of a plus the derivative of a times h. Thus, f of 5 plus 0.5, wherein a is equal to 5 and h is equal to 0.5. Following the formula, it would be f of 5 plus 0.5 times the derivative of 5, which is equal to 6, and f of 5 is equal to 4. So 4 plus 0.5 times 6 is equal to 7. Thus, the rate of change of f of 5.5 is equal to 7. For the second example, the position of the particle moving along a coordinate axis is given by s of t equal to t cubed minus 18t squared plus 96t plus 35 is greater than or less than 0. First, find the Vt, and second, what time would be the particle at rest. To find Vt, we need to find the derivative of the function st. The derivative of t cubed would be 3t squared, then the derivative of negative 18t squared would be negative 36t, and then derivative of 96t is equal to 96. So Vt is equal to 3t squared minus 36t plus 96. Then to find the time the particle would rest, we first need to set Vt is equal to 0. So it would be 3t squared minus 12t plus 96 equals 0. Then factor out. The factor of 3t squared minus 36t plus 96 is equal to 0. Then it is factorable by 3. So 3 times t squared minus 12t plus 32 equals 0. The next factor is the expression t squared minus 12t plus 32. The factor would be 3 times t minus 4 times t minus 8. Thus, we can have a time of t minus 4 equals 0 or t equals 4 and t minus 8 equals 0. Then finding the answer would be t equals 8. Thus, the particles at rest at t equals 4 and t equals 6. Thank you for listening.